Hello, shall I start the class? Anyone who
Yes,
is there?
ma'am.
Yes, Kapla ma'am. Okay. I think sheet I already shared with all of you. Have you seen the sheet available on WhatsApp? Okay, fine, good. So if you have got the sheet, shall I start today's session? I'll share my screen first. Give me a second.
Ma'am, is today's topic ANOVA?
No, we'll study the t-test.
Okay, so on the WhatsApp group, I haven't received any sheet link. Maybe if it can be done again, because I checked it twice. I do not have it.
I think anyone who can confirm me whether the sheet is available there or not on WhatsApp.
Yes, ma'am. Sheet is available on the WhatsApp group.
Yeah. Kapila ma'am, you please check. So I'm sharing my screen. Give me a second. Okay, so I think I shared my screen. Is visible?
सेट करो अभी
Sorry? Fine. So shall I start, everyone? Someone has Ashish sir? Ashish sir?
मैं तो कह रहा हूँ फोन लाके लेके करता हूँ
Ashish sir, can you mute yourself?
हाँ जी आपको तो प्लेसमेंट करते हैं मिलके सर
Ashish sir?
हाँ
So will you mute? Hello, Ashish sir, can you hear me?
रुक जाए यार हाँ मैं देख रहा था बहुत बढ़िया लगा हुआ कि नहीं लगा हुआ चेक कर रहा था ना किलर पे लगती नहीं लगती इतना तो 200
Ashish sir, can you mute yourself?
लगी होती कैसे
Anyone who is there from RFI? Yogra sir? I think sir is muted. Shall I start? Yeah. Okay. So yesterday I talked about the non-parametric test, right? Today is the day of parametric test. So firstly, we'll see what is parametric test, and then we'll talk further about the t-test. So parametric tests are the tests which consider the normal distribution of the data. So these tests are generally for understanding, or for these type of tests are considering the normal distribution of the data. Apart from this type of tests we are using to infer the population parameters based on sample statistic. Right? So means, or you can say when we consider the population parameters, in that case we are calling them as a parametric test. Right? So these can be the probable definitions of parametric tests. Generally, when we are considering the normal distribution of the data, then we are talking about the parametric test. When we are aiming to infer, or when we are aiming to take an inference about the population parameters using the sample statistics, that means parameters are nothing but these are the characteristics of the population. So to assess the population characteristics, we are considering the sample characteristics. In that case, we will use the parametric. Also, when we are considering the population parameters in our study, that way we can use the parametric tests. There are various parametric tests available, such as
Angela, ma'am.
yes.
I'm sorry to interrupt you, but still somebody has switched on their speaker and it's very disturbing. We cannot hear you clearly. I think it's Dr. Mukesh Kumar Shukla. His speaker is on.
Okay. Mukesh sir, can you hear me? Mukesh sir, will you please mute yourself? Sir, mute the mic. Mukesh sir. I think today no one has joined from the RFI team. RFI, anyone? Ma'am, I think Mukesh sir is forgot to mute himself. Will you please do that? Fine. Thank you so much, ma'am. So do I need to repeat? Kapila ma'am?
Yes, ma'am, please.
Yes, ma'am. Okay. So I was talking about parametric tests. I said the tests which are generally bothering about or considering the normal distribution of the data. In that case, we can say we are talking about the parametric test. Second case, we can say when we want to infer the population parameters using the sample statistic, means when we want to infer about the population characteristics using sample characteristics, we are using the parametric test. Or when we are considering the population parameters, in that case, we are talking about the parametric tests. Some of the parametric tests I have written here as T, Z, ANOVA, regression, etc. can be the part of this particular parametric test category. Right? Generally, these tests are based on assumptions such as normality of the data, homogeneity of the variance, so these are some of the common assumptions generally the parametric tests are considering for applying them. Means if we are having the data, we need to generally test such kind of assumptions, and if the data is meeting these assumptions, we can go further for the applying of these parametric tests, right? So these are the common. According to the different tests, these can vary also. Means these are the common. Generally, we are finding them in almost all of the parametric tests. Apart from that, tests will be having their own other assumptions, right? Then talking about further, as I have mentioned already here, these are some of the parametric tests, right? So if I talk about today's session, here we will talk about the t-tests, right? So question comes, T or students t-test is generally we are using. Before saying anything on this particular thing, I need to tell you this thing. When we talk about the statistical test or the parametric or maybe the non-parametric test, each and every test is having its own purpose, right? They are having the purpose, like say for example, if I am saying when we are using the Z test or T test. So answer is very simple. When we are interested to find the significant mean difference, in that case we are using the T test or Z test. Even ANOVA is also used for the same purpose, right? So when we are talking about the T test,
Ma'am,
yeah.
can you please clarify when to use ANOVA? Sometimes nowadays, I think after having two groups also, people want to use ANOVA because they will get some better results. Is it
I think
that, ma'am?
ANOVA I'm talking about tomorrow, sir. So we'll talk about tomorrow, right? Presently, if I talk about the t-test, so I'll say this thing that when I talk about the t-test generally we are using to find the significant mean difference, right? So whenever you are interested to find the significant mean difference in the categories, generally you are talking about the t-test, right? So there are varieties available in the t-test. We can classify t-test into the one sample and two samples. In the two samples category, we are having the independent and dependent, right? So after this, when I talk about the one sample t-test is a test which consider or which is based on one variable, right? The nature of the variable should be continuous, or you can call it as a numeric, or interval, or ratio scale data, right? So for the one sample t-test, we need to have only one variable available with us, and this variable should be continuous or numeric variable, or you can call this thing that your variable should be measured on interval or ratio scale, right? Then talking about the two samples t-test, if I talk about independent samples, in case of independent samples t-test, we need to have two variables. In these two variables, one variable will be the dependent variable, which will be continuous or numeric, and the independent variable should be categorical with two levels or categories or groups or samples, right? Purpose again here will be the to find the significant mean difference. Always we are finding the significant mean difference in the dependent variable or in the numeric variable. So whether the mean is same of the numeric variable in the two different groups or in the two different samples, that you need to see in case of independent samples t-test, right? Next one is the dependent samples t-test. So here we will be having one variable which will be continuous or numeric, and should be measured twice with the specific time interval or within the specific time interval. Generally, when we talk about the dependent samples t-test, the other name for this is the paired samples t-test. So paired samples meaning is there will be a pairing, and how the pairing is possible when we are collecting the data for the same individual twice, right? Say for example, if suppose our company is saying this thing, if you are opting this particular training program, so your skills will enhanced, right? So before opting that skill development program, what is the value of your skill that you need to measure, and after whatever particular time period they're promising you that after these number of months, if you're doing this particular course, your skills will be enhanced. So after that particular time period, you will again check the skill set or the value of your skill set. If it is increased, so that means that means for the same people you are collecting the data twice. So that is why I have written here, in case of dependent samples, we will be having only one variable, right? And this variable you need to measure twice, or for this variable you need to collect data two times, right? So when I say paired sample t-test, so for example, 10 people, or maybe suppose here I'm writing, suppose there are 5 people. So before opting that training program, the skill value suppose 5, 4, 3, 5, 3 or 5 or 4. And after this, suppose it is coming 6, 7, 5, 7 or 5, likewise. Getting? Clear? I hope it is clear, everyone.
Yes, ma'am.
Yeah. So this way, this is the variety available in the t-test. So if I want to say again about the t-test, I can say this thing. T-test is always we are using when we are interested to find the significant mean difference, right? There are varieties available in the t-test, one sample and the two samples. In case of one sample, we will be having only one variable, that will be the numeric or the continuous variable, and that way you will compare its mean from the population mean, right? In case of two samples, you will be having the independent case and dependent case. Independent case meaning is your two samples or your two groups will be independent of each other. For example, if I want to compare the salary of male and female employees, so in that case, it is clear we are having the salary variable available here, that is the numeric or the continuous variable, and we want to compare the salary of male and female. So the male group and female group are independent of each other. It is like, means male cannot be the part of female group and female cannot be the part of male group. So there will be independence in the two groups. So we want to see whether the mean salary is same for the male and female or not. In case of dependent samples, we will be having only single variable, but for that single variable, तो कुछ काम है? सर, कॉल करो?
अभी बेसिस अटेंड कर रहे हो?
नहीं, क्लास ले रही हूँ।
चलो
कॉल कर।
मेरे को राजावत ने जो भेजा ना, वो
हाँ, हाँ।
समझना था, मैंने कहा इतना ज्ञान।
कॉल करो?
हाँ, अभी
इसकी फ्री होने के बाद 7 o'clock के बाद
7 से एक तो कल मिलेंगे, 29 तारीख लास्ट डेट है ना?
हाँ, तो कल मैं आ जाऊंगी। Okay, sorry. So when I was talking about dependent sample, here we will be having only one variable and we will be having only the single sample, right? Me, suppose I am having only these 5 people sample I am having. So for this particular sample, you need to collect data twice, 2 times in a particular time period gap. So that way, this is a case of dependent samples. There will always be a pairing, right? So this is known as dependent samples. Is it clear? The concept is clear. May we go further? Yes, friends, say something.
Ma'am, I want to ask one thing.
Yeah.
So if I have an experimental research and I have a control group and an experimental group, so in that case, what will I use?
Can you give me the example? What type of study you are going to do?
So maybe just say in academics, I have in a classroom, I have an intervention. So I have two groups. One is a control group and the second is the experimental group, which is studying through the intervention.
You
Maybe
can go forward with the independent sample test.
So that will be independent sample test. Okay.
Fine.
Yes, ma'am.
Yeah. Fine. So if the concept is clear till this, we can go now for performing the t-test now using the Excel. So there you need to go to the sheet named as demo 1 sample. So expecting everyone to open the sheet. Open, everyone. Shall I start?
Yes, ma'am.
Fine. So if you have opened the sheet, you have found in the sheet we are having the height variable. In this particular column, you can find we are having height in inches. I hope everyone is having the same sheet, right? Yes.
Yes, ma'am.
Yes, ma'am.
Fine. Now, as I said, in case of one sample titers, we will be having only one variable or one sample. So you can find we are having only the sample of how many people? It is 12 people. So 12 people data I am having, 12 people's height data I am having. So the one single variable we are having, that is height. So whenever we are talking about the one sample titers, in that case, you need to compare the sample mean from the population mean, right? So here you will write the hypothesis first. Or hypothesis will be there is no significant difference in the mean height of sample and population. Okay, done. Fine, everyone.
Yes, ma'am.
Yeah.
Of course, ma'am. Can't off করে দাও?
Now, after this, we will see how we can use Excel to perform the one sample titers. So once you will go to the data tab, you will click on this data analysis. There you can find, you will go down because all the tests are listed alphabetically. So you'll go down and you can see we will be having only 3 categories. T-test,
Ma'am,
paired.
kindly to share the whole screen, na? If you don't mind.
I think I have shared the screen.
Ma'am, we are unable to see that pop-up window.
Oh, I think you can go to the data analyst toolpack. There you can find
Yeah, we
this.
can.
It's not listed there, so that is why there is no use of sharing that. So you
No
can
problem.
find.
No
I'm just telling you this thing in that particular dialog box. There is no one sample t-test is listed there, right? So you need to use Excel as a calculator only. Is it clear?
Yes, ma'am.
Yeah. Now, question comes, if you need to use Excel as a calculator, so what things you need to find? So you need to see the particular formula which we are using to get the t value. In case of one sample t-test, I have given you that particular formula, which is t equals x bar minus mu divided by sx bar, right? Which says that x bar is the sample mean, mu is the population mean, and sx bar is the standard deviation or standard error of the mean, right? So this way you need to calculate, or you need to have these 3 values if you want to get the t value. Is it clear, everyone?
Yes, ma'am. Yes,
Yeah.
ma'am.
Now, after this, I think I have written few things. If not, you can also type. I'm typing along with you, or one by one we'll go with this, right? So I'll delete all this. Suppose, firstly, I am writing the sample mean, because the formula is firstly demanding you the sample mean. So the sample mean is what? It is nothing but it is the average of your data. So I'll use the average function. I'll select the range. I'll close the bracket and then I'll press enter. It is okay. May I press enter? May I?
Yes, ma'am.
Yeah. Next, after getting the sample mean, you need to have the population mean. Population mean, in case of whenever you're talking about the one sample titers, you always need to have the idea about your population mean, right? So in this case, I think it is already given in your sheet, mu is equals to 66, right? But if suppose, if it is not known to you, right? So in that case, from some of the information, some of the sources, you need to have the idea. Whenever you want to apply the one sample t-test, either you need to have the population mean or you need to assume the population mean. So hypothetical mean of the population you need to have if you want to apply that one sample t-test, right? So that is why in this particular problem it is written that the population mean, which is mu, is 66. So I have written, or I typed here, the mu is equals to 66. This is done. Further, you need to get this standard error of mean. Standard error of mean is nothing but it is your standard deviation divided by square root of the population or square root of the sample size, right? So firstly, I'll calculate here the standard deviation. So standard deviation function is STDEV, and in the range you need to give the range of your data. Done? Done?
Yes, ma'am.
So the standard deviation coming as 1.642941. After this, the sample size, that is n, which is you can get using the count function. Done? Done?
Yes, ma'am.
So the count is 12. Now the standard error of mean will be standard deviation divided by SQRT square root of the this. Done?
Yes, done, ma'am.
Done. So the standard error of mean is 0.47. Now, according to the formula, we are having all the three things now. Now we'll get the T calculated value. Done? Which is, so for getting this, I'll do one more thing. I'll firstly get the numerator value. Numerator is what? This is sample mean minus population mean, right? So equal sample mean is this minus population mean is this. Done?
Yes, ma'am.
Done. So this is the numerator. Now we'll get the T value, which is this difference divided by standard error. Done? Done, everyone?
Yes.
Which is 4.921. Okay?
Ma'am, can you show me again, ma'am?
Which
The
one?
Ma'am, the numerator and T.
Numerator. Numerator is the sample mean. You need to see your formula, which is saying sample mean minus population mean. So that wherever those two values are written, you need to take a difference of those. That is sample mean minus population mean. So which is 68.33, which is 68.33 minus 66. Done?
Yes, ma'am.
And the T calculated is what? This is this x bar minus mu, which is you already calculated. This numerator is your x bar minus mu divided by standard error of mean. So this is also you have calculated. So the ratio of these two will give you the calculated T value. Done?
Yes, ma'am.
Now, question comes, now you need to make a decision. So for making the decision, yesterday I told you two rules, thumb rules. Anyone who can recall?
If p is less than 0.05, then hypothesis is null. If p is more than 0.05, then the hypothesis holds.
I think written correctly. This is what you said. Okay, sir.
Yes, ma'am.
Yeah. So this is the first thumb rule. Second thumb rule also I have told you. Based on calculated and critical value. So if calculated value is less than the critical value, so we need to accept the null hypothesis. And if calculated value is greater than critical value, we need to reject the null hypothesis. This is the thumb rules which I told you yesterday, if you can recall, right? Now, as we are having the calculated value of t, if suppose now if I'm having the critical value of t, this will make my problem, or this will resolve our problem, and that way we can make comparison in those two, and we can decide whether we need to go with the null hypothesis or not, right? So here, if you want to get the t critical value, so the function is t dot inv 1 minus alpha and df. Alpha is what? Anyone who can tell me what is alpha?
Alpha is by default we keep 0.05. That is the
Level of significance. Alpha is your level of significance, which is generally we are taking as 5% or 0.0, right? So now we'll get the t critical value, right? So t critical value is demanding you the two things. Degree of freedom also you need to have. So suppose degrees of freedom is n minus 1. N is this 12 minus 1 will give you the degrees of freedom, which is 11. Ma'am, kuch kaam hai? So which is 11, right? Now, for getting the t critical value, we are using the t dot inv function. Inside this, you need to provide the probability, which is 0.95, comma, degrees of freedom is 11, and then you can press enter. Is it okay? May I? It is done.
Yes, ma'am.
So this is your critical value of t. Now, you need to make the comparison. So the thumb rule is written here. So you can tell me whether I need to go with the null hypothesis or not.
No, here we have to reject the null hypothesis because the calculated value is more than the critical value.
Yes. So here we can say this is, I think, correct in our case. Our calculated value, which is 4.92, greater than 1.795. So we are going to reject the null hypothesis. And if we are rejecting the null hypothesis, you can see this is the null hypothesis which we have written. So we are not going with this null hypothesis, and we are going with the alternative hypothesis. So which we can say that there is a significant difference in the mean height of sample and population. Means that if you can find the sample mean height is 68.33 and population mean height is 66. So the difference in these two is significant according to our results. Is it okay? Is it fine, everyone?
Ma'am, this we can infer just by comparing the arithmetic values. So why do we need to, go for this extensive calculation?
Not getting.
This we can infer just by comparing the arithmetic values.
Okay, you are
between the
saying
sample
by
mean and
comparing
population.
these two values, you are saying this thing.
Yes, ma'am. So why can't we just infer something with this, and can we avoid all these things?
Yeah, making sense. It's a good question, I must say. Okay. So according to your question, sir, answer of mine will be, when I talk about mathematics, in maths generally, if I say 4 or maybe 5 and 5.5, are these two similar?
If you are looking for extremely accurate answer, then it's not similar. But
Yeah.
in general, it is similar.
I think I cannot write this mathematically. Can I?
No, we cannot.
Yeah. But when I talk about statistics is generally identifying the difference in these two values is significant for us or not, right? Say, for example, there is a company who is producing water bottles, right? Company is claiming the water bottles produced by them is storing 1 liter of water, right? Now, to check the claim of the company, suppose one quality inspector came and he or she has collected around, suppose, 20 bottles, right? And what he has done, he has poured water in all of the bottles, and then he has measured that what is the quantity he stored in the bottles, right? Suppose in some of the bottle, the water quantity is 999 point, suppose 08, maybe 998.5, maybe 1000.02, then 997 point, suppose 78, likewise. So that way, on all the 20 bottles, whatever the quantity he has poured, he is measuring, he is noting down somewhere, and then suppose he is taking the average of that, right? And suppose that average is coming, is it okay? Getting?
Yes, ma'am.
Now companies was claiming that the bottle is storing 1 liter, that is 1000 ml, but the average is coming as 998.69 ml. So now you need to tell me whether we will reject the claim of the company or will accept the claim.
Reject, ma'am.
We will reject the claim. Okay. But I think I will not reject the claim. Does it matter for me? 0.002 ml water?
Oh, ma'am. But mathematically, the number
We
is
are talking about
actually.
it statistically, because here that is what you need to see, whether I need to take a strict action for such kind of thing or not. So I think it is like, we can say this thing, it is by chance. This mistake is coming by chance. The person has not done it intentionally. If suppose this average is coming, suppose 900 ml, that way it is a concern. We need to find that there is some problem in manufacturing process or something. Getting me?
Yes, ma'am.
So that is why when I talk about statistics, you need to always find that these two figures are, means when you are looking at the values, it is telling you that significant difference, the values are different. But whether that difference is significant for me, I need to make some what I can say, corrective measures or actions for improving it or not. That you need to decide using these statistics. Is it clear?
Yes, ma'am. You made your point. Thank you.
Yeah. Fine. Now, this was the one sample t-test. Now further we are talking about the next category of the t-test, which is independent samples. So the next practice sheet, I think it is for you all. You can use this practice sheet for your one sample t-test practice. You need to open now demo independent. The sheet name is demo independent. Done. Fine, everyone. Shall I?
Yes, ma'am. Please go ahead.
Yeah. Now you can see we are having the study hours data available in the two different groups, the female group and the male group. So females, how much study or how much time they are studying, maybe in a week or something, these hours are given with us. Similarly, for the male, the hours are given to us. Here question comes, I need to find whether the mean study hours are same for both the groups or not. So that means purpose is quite clear. We need to see the mean study hours in the female and male group is same or not. According to the requirement of independent sample status, you can find here we are having the study hours, which is the numeric variable, right? And we are having the gender with two groups or levels, right? Which is your categorical variable. Done. Done.
Yes, ma'am. Done.
Right. So purpose is, I already told you, purpose is you need to compare the study hours, mean study hours. So it is indication, the according to the variable, according to the purpose, we will go for the one independent sample status. So our null hypothesis will be class le rahi bachcha online. So your null hypothesis will be there is no significant difference, or there is no significant mean difference. Maybe there is no significant difference in the mean study hours of male and female students. Done. And this will be my alternative hypothesis. Done, everyone? Shall I proceed?
Yes, ma'am.
Yeah. After this, when null hypothesis we have formulated, we are having data available, and suppose we have set the level of significance as 5%. Now we need to perform independent sample status. So we'll go to the data tab, and here we'll select this data analysis toolpath. From this dialog box, you need to select the details. You can go down and you can find paired two samples will not be the appropriate.
Ma'am, your dialog box is not visible.
Okay, just a minute. Fine. Now visible?
Yes, ma'am. Thank you.
Yeah. Now we need to go down. There you can find we are having the three variety available in the t-test, which is t-test paired two sample for means. So our samples are not paired. One sample is of the male, one sample is of the female. So there is no pairing in the samples. That means this test will not be appropriate test for us. Next two are the t-test two sample assuming equal variances and assuming unequal variances, right? So here you can find, if I talk about equal variances and unequal variances, So there is a what I can say assumption of the t-test, independent sample t-test. There you need to check whether the variance is same in the two groups which you are considering. If variance will be same, you will go with the first option. If variance will not be same, you will go with the second option. But till now, I think we have not calculated, we have not identified the variance is same or not, right? Either you can check that first, and if you are not checking that, you can by default go with the unequal variances case, right? Means generally when we are teaching in the classes, because for students it is very what I can say technical kind of things to understand. So the testing of the variances we are skipping in the classes when we are teaching to the students. But being an academician, if you want to check the variance kind of thing, so there is one more test available in this particular dialog box named as, you can go up and can check F test to sample for variances. So if you want to check firstly variance is same or not, you can go with this. If you are not checking this, you can go directly with the unequal variances case. It is clear to everyone?
Ma'am, one question. If its variance is different, we will go for F test.
I think we haven't checked. I said for checking the variance, we are going
Excuse me,
for the.
ma'am. Sorry for interruption. Because, ma'am, we are discussing again about variance and using F test also. So, as it was, I was again, ma'am, because I had this confusion. Can we use somewhere this ANOVA related test here instead of T test?
Sir, you're not getting my point. ANOVA is a different test. In ANOVA also we are getting this means in case of this Excel, you are not getting that. But when we are using ANOVA, using the SPSS or some other software, so there you are getting the Levens test. That Levens test is nothing but that is the F statistic, which is here listed as this.
Right, that is right, ma'am. But F is there common in both, in this also, that also. So here we are using T distribution. There we are using, we are not using T distribution, but we are calculating the difference in variance only, significant difference of variance.
Hmm.
Here also we are calculating through variance only.
Hmm.
So that is the doubt, ma'am.
So, sir, so what is the question?
Because in both the tests we have the variance as one of the mediator variable.
It's an assumption of both the tests
Yes.
that the variance
So
should be same.
and here in this we are having some T distribution assumption,
Hmm.
which we don't have in ANOVA.
Hmm.
So that is a doubt.
So that is,
Why can't we use ANOVA here?
so generally ANOVA we are using when we are having more than two categories that we are discussing tomorrow, as I said. In case of only two groups, rather than going for the ANOVA, we are generally using the t-test.
Okay. Okay.
So I think I don't know how many of you are getting clarity about this or not. As I said, every test is having certain assumptions. So in case of t-test, one of the assumption is that variance should be same, right? Equal variance should be there. Homogeneity of variance should be maintained by your data or by your numeric variable. So for checking that assumption, here in Excel, there is one option available, as I said, which is named as F test to sample for variances, right? If you want to test or if you want to check that assumption, you can go with this. And if you are not interested in checking that assumption, I said you can directly go with the unequal variances case. Means you can directly select this one. Is it clear? Yes or no? Yes. So do I need to check this assumption or whether I need to directly go with the unequal variances? Yes. Anyone? Any suggestions from your side?
Can we check the variance? Proceed with unequal variances.
I think one of you are saying unequal variances, one of you are saying go with the variance testing. So what I need to do? I think there are so many members. Please suggest what I need to do.
Ma'am, as per the FT test of 2 sample, we have observation 6 and 5 and difference DF shows 5 and 4. The critical 110 shows 6.25. So we can go with unequal, na?
Okay. I don't know what you are saying to me. I think you are saying there are total 6 observations.
Ma'am, you
There
no
are
no no no.
observations.
Sorry. Ma'am, we have done the way you said. If you do not understand, you can go with F test. F test. जब उसे देखा तो पता चला है कि डिफरेंस है 5 और फीमेल 5 है और मेल 4 है. एफ की वैल्यू हमें फ्रीक्वेंसी दिखा रही है 7.37. डिफरेंस है उसमें. So we have to go with.
Ma'am, please you wait. Please wait. I think I am asking the different question. You have applied that. You please wait. I am asking whether I need to go for the F test checking or I need to go for directly for the unequal variance. This is my question is, if you have applied, please wait. Those who have not applied, they will not getting what you are saying. So my question is, do I need to apply F test firstly or I need to directly go for applying the test 2 sample for the unequal variance? This was my question is. So I want the suggestion from your side. So what I need to do? You people need to suggest.
No, unequal variance will directly go.
Okay, fine. So I'll select this unequal variances. Click on OK button. So the dialog box will appear. There you need to see this thing. It is asking you to go provide the range of your first group, right? So I'm selecting the range of my first group, which is this. In the second box, I'm selecting the range of my second group, which is this. Hypothesized mean, I'm not assuming anything, right? Next is labels. I think I selected my data including these labels. So I'm selecting this checkbox. By default, alpha value, that is level of significance, is 5%. If you want to make any changes, you can come in the box and you can make the changes in the percent value of this, right? Output options are 3. I'll go with the first one and I need to give here the blank cell where I want to generate my output. Till here, everyone is okay? Shall I proceed with okay?
Yes, ma'am.
Yeah. Click on OK. You will be getting the output for unequal variances. There you can find we are having the 2 groups, male and female. So the mean study hours for female are 33 and for male it is 24.8. The variance in the female study hours is 160. In the male study hours is 21.7. Observations are 6 and 5 in female and male groups. Hypothesis mean we haven't passed anything, so it is coming as 0. Degrees of freedom is 7. T-stat means the T calculated value, which is 1.47. Now, if your hypothesis is made for the one tail test, you will go with this P value and with this T critical value. But if your hypothesis is of 2 tail tests, you should go for this P value and this is the T critical value, right? So the hypothesis which we have formulated, it is for the 2 tail test, right? So we will select these 2 either. So I'll make my comparison on the basis of these 2. So if I talk about the P value is 0.18, which is greater than 0.05. So if this is the case, what I should do? What should I do? Yes.
Reject the null.
We are going to reject. No, we are going to accept. Why we are going to reject? We will accept the null hypothesis.
Yeah, sorry.
Yeah.
It's great to them.
Yeah, we are accepting the null hypothesis. That means we are saying there is no significant difference in the mean study hours of male and female students. Is it clear? Is it clear to everyone?
Yes.
Now, I'll tell you in the second way also, those who wants me to perform according to the F value. Now, again, I'm going to the data tab, data analysis, and I'm selecting this, and then I'll go for the F test. I'll click on OK. I need to provide the range of my first set of sample, and then second sample range I need to give. Then I'm selecting the label. I'll go with the first option, and then now those who want me to perform this, they can check this. If not, you can skip this, right? Now you can find here mean and variances, everything is coming here. Number of observations are there, degrees of freedoms are there. Now the F value is 7.37. This is the combined variance value, you can call it, with 7.37. Now the P value and the critical value is mentioned here. So if you will go with, if suppose you are assuming in case of F test, in case of this F test, your null hypothesis will be variance is equal, right? Generally, we are formulating the hypothesis for the two-tail test. So if your critical value is available for the one sample or one tail, what you need to do, you need to multiply this by 2 to convert it into the two-tail test, right? So it is now in the two-tail form. Now you can see it is greater than 0.05. That means we'll accept the null hypothesis. And when we are accepting the null hypothesis, we are saying variance is equal. Is it clear? Is it clear? Is it okay, everyone? I don't know who was speaking to me initially. Those who one of you have performed initially the F test. Was it Pooja, ma'am? I don't know the name.
Yes, ma'am. Pooja.
Pooja, ma'am, I think the same values you were getting.
Yes, ma'am.
Yeah. You need to see in case of the F test, your null hypothesis will be variance is equal, and you can make your decision on the basis of the P value or the critical value. But in case of F test, it is providing you only one tail T test or one tail F value. So that I converted into the two tail by multiplying this value by 2. So I have converted into the two tails, right? So which is this. Now I need to compare this by the level of significance, which is 5%. So I can make a comparison that this obtained P value is greater than 0.05. So I am going to accept my null hypothesis, which is saying variance is equal. But we have applied unequal variance case, right? So now we need to apply the equal variance case. So we'll go to the analysis tab, and now we will select the equal variance and then click on OK. Provide the range of one or of the first sample, then of the second sample, then labels I'll select, and then the output range I need to select, which is suppose this. Done. So you need to see whether your results are still same or not. So you can compare this. The P value is this, which is greater than 0.05. So you need to say this thing. You are going to accept the null hypothesis. Done.
Hello,
Yes, sir.
ma'am. I have few questions. In t-test, when we are assuming unequal variance,
Hmm.
the degree of freedoms comes out to be 7. How that? When we are assuming, yeah.
I think it is a calculation of the software, sir. Generally, it is n1 minus 1, n2 minus 1.
N1.
n1 minus 1 plus n2 minus 1.
So it will be 5 into
It
4
should be 9.
Plus so 9. So why it's 7 here?
I think this is software, sir. I cannot comment on that. because it is generated by software. I have not made any calculations here. You can check here in case of equal variances, it is coming correctly.
Yeah. And then now in F test, two samples for variance, we have multiplied p value by 2. F value of one tail into 2. But we have not multiplied the F critical into 2. Why so?
That you can do, sir, because I'm making my decision on the basis of this, no? Because
So we
there
are
will be
comparing it with the critical only, na?
no. I have made comparison using this p value.
No, this p value 0.07 is compared with which one?
Level of significance 0.05. I have written here.
We are comparing with the level of significance.
P value always is compared with the level of significance, sir. P value always you will compare with the LOS, level of significance.
But when we are doing the t-test two samples assuming unequal variance, there also we compared p-value with the critical value.
Did I? No.
So there also we are comparing it with the 0.05.
No, I think I have written here.
Okay, I assume that we are comparing it with the critical.
No.
Okay, thank you, ma'am.
Okay, sir. And here also I have compared with that only. In all three cases, I compared it with the p value will always be compared because p is a probability value, percent value. So how come I compare it with some numeric value?
Okay, thank you, ma'am.
Yeah. I hope it is clear to everyone. As sir, I think Harneet sir, I don't know who was talking to me. I think I got an answer. I think it is just came in my mind. When we are talking about the unequal variances, in that case, the calculation of degrees of freedom formula will be different, sir. So that is why it is 7. Formula is different in case of this, and that is a very big formula. Not like this.
Okay, ma'am.
Yeah.
Thank you.
Yeah.
Ma'am, excuse me.
Yes.
Ma'am, for 2 sample, it may be n minus 2 because we have 6 minus 2, 4 here for female, and for male, 5 minus 2, 3. Formula minus
No.
2 or 2
It
sample.
is not that formula. Formula is very big. I think I have there in some of my PPT somewhere. I need to find. It is there. I need to check it.
Ma'am, no issues. You can share it later on in the group.
Yeah, I think I have seen. I have written somewhere in some of my slides or somewhere I have written this. The formula is little different in that case. This will be the formula. Clear?
Yes, ma'am. Thank you so much.
Yeah. Fine. So I think independent sample status is clear to everyone. Shall I proceed? Yes.
Yes, ma'am.
Fine. So now you need to open the second, or maybe I think second last, named as paired. This sheet you need to open now. Done, everyone? Shall I?
Yes, ma'am.
Yeah. Now you can see we are having the weight in pounds, right? So suppose any of the gym or maybe any type of company which is offering and saying, if suppose you're opting for this particular diet plan, so your weight will reduce, right? So around 8 people have opted this. So before opting the diet plan, what is the weight of the individuals which are mentioned in the first column named as before, and after opting this, after certain number of months or something, again the weight was taken for those number of people, and the weight obtained is mentioned in the after column. It is clear? So suppose this is a small caselet, right? Before and after condition of the weights is given here. Before opting the diet plan, what was the weight of the people, and after opting it, what was the weight? So these two columns are mentioned here. It is okay.
Yes, ma'am.
Now we want to see whether the any significant change or mean difference coming in the weight after opting the diet plan or not, right? So suppose our hypothesis is there is no significant difference in the mean weight before and after opting the diet plan. Alternatively, the hypothesis is there is a significant difference in the mean weight before and after opting the diet plan. This is the hypothesis. It is clear? Done, everyone?
Yes, ma'am.
Now, if this is a case and we have formulated the hypothesis and suppose level of significance is 5%. So to perform paired sample status, we'll go to the data tab, then data analysis tool pack, and then we'll select the t-test paired to sample for means. This is what we need to select. So shall I? Everyone has located this test? Yes, may I?
Yes, ma'am. Yes, ma'am.
Click on OK. Then you need to provide the range of your first set of data, and then we need to select the second column. Done. After selection, hypothesized mean difference, we are not assuming any mean difference in the mean, so we are not passing anything here. Coming and selecting the labels. I think I select A3 is this. Yes, I selected my data including the labels, so I'm checking this labels box. Alpha value by default is 5%. Output I'm generating in the same sheet here. So is it fine? Shall I go? Press OK. May I?
Yes, ma'am.
Okay. So I think we generated the output now. In the paired two sample status, you can find we are having a descriptive statistics initially. Mean weight before opting the diet plan was 169.625. After opting, it is 150.25. Variance in the weight was 65.125 and presently it is 121.929. Total observations are 8 and 8. Pearson's correlation is coming as minus 0.17657. Always when you are performing the paired sample status, you will always get the correlation value because there is a pairing in your data. So it is always producing you the mean value or the correlation value, right? So you can find the correlation value is very small, which is 0.17 only. 17% correlation or relationship is there in your two variables, right? But the relationship is negative, means if one is increasing, other is decreasing kind of thing. Then hypothesized mean, we haven't passed anything, so it is coming as 0. The degrees of freedom is 7. Calculated t value is 3.70687. Then the p value for one tail, then the critical value for the one tail is given. then the p-value for two-tail, and the critical value for the two-tail. So you can see, if I will talk about the p-value, which is 0.00759, you can see this is less than 0.05. Yes. It's fine. Is it fine, friend?
Yes,
Yes,
ma'am.
ma'am.
Yes. So if it is a case, what I need to say?
Reject the null hypothesis.
Yes, we need to reject the null hypothesis. So when I'm rejecting my null hypothesis, I'm concluding that there is a significant difference in the mean weight before and after opting the diet plan. That means the difference is significant here, right? Now, if I want to comment on the effectiveness of the diet plan, I can compare the mean values because difference is existing in the means. That is the significant difference. So I can see before opting the diet plan, the mean weight was 169.625, and after opting it, it was 150.25. So that means there is a reduction in the weight. I can comment this thing that the diet plan was effective because weight has reduced and the significantly change has noticed by the test. Is it okay?
Yes, ma'am.
Yeah. So this way we can perform paired samples t-test using the Excel. Next sheet is for your purpose. You can use this sheet for the practice, right? So now I will summarize the whole session, and after that, if you are having any query, you can ask me the questions, right? So I summarize the session on this note that today we discussed the concept of parametric test. We tried to understand that what is parametric test. Right. After that, I explained you. So I have given you the name of some of the parametric tests. We have seen the purpose of using the t-test. Why we are using the t-test? So I said, whenever you are interested to find the significant mean difference, you are using the t-test, right? Then question comes in the variety of the t-test. So we can say there is one sample t-test and the two samples t-test. In case of one sample t-test, we are always comparing the sample mean with the population mean. We want to see this thing that whether the sample is belonging to the same population or not. If sample is belonging to the same population, we can say this thing that the sample mean is same as the population mean. So you need to compare sample mean and population mean in case of one sample t-test, right? So we have seen this thing that we will be having only one numeric variable in case of one sample t-test, and we can use Excel as a calculator only. That means we need to keep the formula of the one sample t-test in the mind, and then step by step we will go and we will find the sample mean, we will find the standard error of mean, and then we will get the the t calculated value, and using the t.inv function we can get the t critical value, and then we can make comparison in both the two values, and that way we can decide whether we are going with the null hypothesis or not, right? After that, I tried to explain you the independent samples t-test under two samples category. So in independent samples t-test, we understood this thing that we will be having the two independent samples, and in those samples, whatever variable we are measuring, we need to see whether the mean is same in both the groups or not. That means we are interested to find the significant mean difference in the variable in two different groups, right? We have seen how to formulate the hypothesis for independent sample t-test, and we have seen that in case of the Excel, we are having the two varieties for independent sample t-test. First one is the equal variance, second one is the unequal variance. So unequal variance meaning is that if you are not having the idea of the variance of your numeric variable, whether the numeric variable is keeping the same variable variance in both the groups or not, in that case, if you are not having such idea, you will go with the unequal variances. And if suppose you are applying the F test using the Excel, you can decide whether the variance is equal or not. And if variance coming as equal, you can go directly for the equal variance test. If variance is coming unequal, you can go for the unequal variances. And if you are not testing or if you are not checking the variance, it is suggestive you should always go with the unequal variance. right? So this is what we have seen. Lastly, I explained you the dependent sample status, that is the paired sample status. So we have seen the concept, and then we have seen according to the available data how we can perform the paired samples or the dependent sample status using the Excel. And the main thing, when I'll summarize my session, I'll say main thing is that you need to only understand whenever you're talking about means most of the time it happens. Generally, students are talking to us, ma'am, it is very confusing which test we need to opt for. Always the test will be guided according to your objectives. So you need to see what objectives you have set. What is your purpose? If your purpose is clear, it will always give you a clear guidance which test you need to opt for. And then your hypothesis will always be in accordance with your objectives. So that way, if the proper sync is maintained by you, it will always guide you correctly. And further, you need to see according to the test, because tests are indicating you what type of variable you need to have, and then what is the purpose. And if all the things are clear to you, you can select the test according to that, and that way you can apply the test using any of the software, and that way you can make the better conclusions, right? So I think this is about the session which I delivered today. Now platform is open for questions and answers. If you are having any, you please ask. Yes. Any questions? Okay. So can we call up for a day? Can we call up the meeting for the day? Yes.
Yes,
Yes,
ma'am.
ma'am.
Okay. I think it's very difficult to.
Ma'am, can you send this updated Excel sheet also in the group, because you have done a lot of updates in that Excel sheet.
Okay, sir. I think I haven't saved this sheet. I have closed. I need to check if it will be available. I'll share with all of you.
Okay, ma'am. Thank you.
Yeah. Thank you, everyone.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you so much, ma'am. So I think I don't know anyone who is there from the RFI team. Ma'am, are you there from RFI? Okay, I think we can call off the meeting. We can leave the meeting. I think no one is there. Maybe busy somewhere else or something.